So hello, in this video we'll try to show you continuous integration and continuous deployment on top of docker112, which is the latest version of Docker. So this is the plan for the demonstration. So in the first, we have two actors in this video. The first one is a new developer that will come to the company, and in the phase one we will show how he will be able to deploy his own development environment and as well the build environment that he will be able to use. Then we will switch to our second actor, which is the ops guide. This is phase two, and we will show how to configure a Docker cluster for production usage. Then we will switch back to our developer, and in phase 3 we will try to show how he will be able to push code and how the testing will happen as soon as you will try to do that. In phase 4 we will assume that the code is okay, and we will show how the code could be deployed on the production environment. And at the latest part of this video is phase 5, and in this phase we will show how the ops guy could scale up the application front end, and also we will try to show you how the cluster will react in case of issue. We have a GitLab on our infrastructure, and part of this GitLab we have a project called CI. The project was done by Pierre-Antoine, and part of the GitLab we have a runner section that will be, this is an external tool that will be used for testing. Then now we are in our CSA tools, and we have created two services, one for development, one for build. So the first one I will deploy is the one for the build environment, and this will create a runner and a build machine that we could use for the continuous integration, continuous deployment testing. So I may have just ordered the services, and this services is using a Docker machine, which is an external component of Docker, in order to deploy Docker engines on various hosts. And we have more or less the same behavior with the development environment or development services, and this will deploy again using a Docker machine system on which we will have container with Clone 9 installed to have a complete autonomous development environment that could be that is web-based. So we can see that our services are in currently progressing from transitions to deployments, and the both services will be in deployment soon. And in the meantime, so we will switch to the ops part to show you the creation of a Docker cluster. But before that, I would like to show what happened at the DockerCon. So we have the enterprise version, which is called Docker Data Center, and this is the closed source solution for enterprise. This is using the engine 1.10.3-CS3. If we want to build a cluster using this version, we need to add the Swarm component, which is for building the cluster, as well as the distributed key value store, which is called etcd. So to install that, it is based on containers, so we will have system containers in the solutions to create our clusters. In the open source world, this is more or less the same. We have the engine 1.11, and we need of course the Swarm component, and as well a distributed key value store, which could be Zookeeper or Console or etcd. But with the DockerCon, Docker announced the engine 1.12, and this was released the 14th of July 2016. And there is not anymore the need of external components like Swarm or the distributed key value store because it was integrated into the engine. So this is really the amazing features provided by the 1.12 engines. And in this demonstration, we're also using a DAP file, which is a file for describing services. And this part is still experimental, so that's the reason why we are using the experimental engine. So if you want to reproduce this demonstration, you need the experimental version of Docker. Okay, so now I will hand over to Pierre-Antoine and he will show you how to create a cluster.
Hello everyone. So now we will try to create a cluster on our three nodes. So here we have our free terminal. So we are connected on the node. First, we will initiate the cluster with the command docker swarm init. So it will create a manager. We will see the manager pop instantly on our little application. So it's a demo app. And now we will copy paste the command provided by Docker to add worker to this swarm cluster. So we will go first on the worker one node and simply adding the worker with the command provided. And finally, we will go on the last node to copy paste again the same command. And we see them pop instantly in the demo app. So with this new Docker version, you just seen how easy it was to create a cluster ready for production and how it can be simply done with only two commands. So just to recap the environment we just deployed, we have our two VM, the dev and build machine, which are deployed on OpenStack. And on the other hand, we have our Docker node. So we just created the Docker Swarm cluster in it, which are deployed on VMware. It could have been done on any public cloud provider like AWS or Azure, for example.
Back to our new developer and the services, you can see that the both services has been deployed. So if we look at our GitLab instance, and if I refresh the screen, you can see that now I have a runner ready, and this was installed by the build services. And now if I look at the development environment, I can click on the service. It will show some information about the services, and I have a direct link to the application. So if I click on it, the Clone9 application is loading. Okay, so I'm now within a browser and I can open a terminal, and this is completely online and I have a full environment to develop my application. So I open the terminal and what I will do, I will get the files for my project. So I'm using git clone and the URL of my GitLab instance in order to get the project. Okay, so now I have the files of my project. So I'm just go into the correct folder. I can see all the files. Okay, so in the right part I have the terminal, and in the left part I have a tree with all my files. Okay, so I'm gonna go in the dev part, and in this dev part I'm launching the cloud.sh script, which will install all the dependencies from my projects. So we created that, but it could be integrated into the service. Okay, so just a couple of words about our application. Our application is really simple. This is an application composed of two services. One one which is the Mongo database, and the other one which is the web frontend based on Node.js application. And the application is quite simple. This is a simple counter, and each time the user will log to the web page or refresh the web page, it will increase the counter that and the value will be stored into the MongoDB application. So to illustrate how the application is composed, um, we are using the Docker Compose file. So Docker Compose is an external tool, part of the Docker landscape. And the goal of this tool is to specify how the application should be executed on the cluster or on our engine. So in this file, there is three parts. The first part is specifying a driver. This is a driver, the type is overlay, and so the idea is that this will create a network that will be distributed across the nodes we have just deployed. Um, and then we have the services part, and you can see that we have the demo CI, which is the front end of our application, that it will be built from the code of our project, and we also have another service which is the DB part, and this is built from the Mongo image directly available from the Docker repository. So now this is the workflow of our environment. So on the development virtual machine and the Cloud9 application, I can develop my code. So as soon as I will push that code to GitLab, the continuous integration testing will be run on the built virtual machine. And depending of the status of that code, it could be okay or it could be bad. If it's okay, I will be able then to do the continuous deployment. So as soon as I will merge that code to my master branch, the code will be pushed to my development environment we have just set up as a cluster. To illustrate that, so I'm gonna create a new branch. So I'm currently on the master branch. So I'm gonna create a new branch with git checkout -b, and I will call that change title. Okay, so this is good practices when you want to create a new modification on your code. Okay, so with the Cloud9, I will change the index.html, which is the main file of my application. I will try to modify the title of my page. Okay, so this title will be checked because we have a unitary test that will ensure that the title is correct. So I'm gonna commit the changes. Change title to produce an error. Okay, because this code is not compliant with the unitary test I have. Okay, and because I'm not a good developer, I will try to push that code without checking my code locally. So here you can see that I have my GitLab, and as soon as I will push um, the code, so I'm using the command git push origin and the name of my branch, change title. Okay, I need to set the correct credential in order to be identified on my GitLab. Okay, so the code is pushed, and as soon as it is pushed, I can refresh my pipeline page in my GitLab, and you can see that tests are running. So right now the tests are in progress. And if I click on the tests, they are failed. So you can see that the tests consist of, we have got the dependencies from the application, and at the end of the screen you can see that the error. We have an error to test this code due to an incorrect title. Of course, in a real case, you will have a lot of unitary tests, but for the demonstration, we only have one unitary test about the title. So I just realized that I make a mistake. So instead of pushing again my code, I can do the test locally. So I'm running the command npm test to ensure to check if my code is correct, and this is still not the case. So I'm gonna fix my title and revert the change I did on the title. So, and I will change the title that will be displayed in my page uh, because maybe what I did before was not the good place, and I'm gonna change this the title shown to the user. Okay, this is just to create a change and to push something. So before pushing this time, I will try my test locally again, and now it's okay. This is passing. So okay, we can see that I have modified the file, and now it's okay. The unitary test is passing. I'm gonna add that file and commit it to my code. So I have just fixed the wrong title, and I have modified, changed some HTML within this file. Okay, so now I'm gonna push my code. Okay, I need to authentify again. Okay, this time I pushed again the code, going to the pipelines in the GitLab. Okay, I have a new test running, and this time it is passed. And it is faster than before because a lot of things have been cached. This is done by the GitLab integration process. So in order to speed up new builds. Okay, so now we can assume I have a good code and that I want to deploy it on the production. So I'm gonna jump to the master branch again, and what I will do, I will merge my modification to the master branch. And in the bottom of the screen, you have the current status of the cluster. So we have our free nodes up and running. And again, so the merge has been done, and now I will commit this code to the master branch and push it to the on the GitLab instance. Okay, I'm identifying again. And in that case, because we are working on the master branch, it will run the continuous deployment process. And so if we look at so we are working on the master branch. Okay, and if I would look at the details of my integration, we can see that the tests are okay. Okay, and I have two new phases. The first one is the build phases. So we can, so right now we are building an images on a container, and the second one is the deployment. And we have speed up a little bit the time, and you can see that now the running phase is in progress, and we have one container which has just been deployed, and the second one which has been also deployed on the cluster. So the two squares you can see on the visualizer are my both containers. One is the database and the other one is the front end of my application. And now if I go to one of my node, okay, so let's go to the master and to the port 8080, which is the port used by my application. You can see that the application is running quite well. If we refresh, we can see that the counter is running. So if I go to the to another node, for example the worker node, it is working as well. So it means that the cluster we have some in the cluster we have some mechanism to direct the requests from the from any node. You can try to access the application on any nodes, and we have a routing process that will bring to the node which is really running the application. As well, if we have multi-nodes, it will load balance between the different containers. Sorry, if we have multiple containers, it will balance between the containers. And what is also interesting, that we can see that our overlay network is also working well because my MongoDB application or container is on one node, and the front-end part of the website is on another node, and this is communicating quite fine between the nodes. So the overlay network was deployed correctly, and so it allows to communicate between nodes. And in that case, we have all the nodes located on the same environment, but we could imagine setup with nodes located on different region or more complex setup. And for the next part, we will try to update that code, and I will give the end to Pierre-Antoine in order to show that.
So back on GitLab, I will show as a good developer this time, so without breaking the test, how we can modify files directly in GitLab and commit it to whatever branch we like. So we will do this directly on the master branch to trigger the same process as René just shown, so the continuous deployment. So now we are browsing the files for repository, and we will edit the index.html. So here we click on the edit button, and we will change the displayed title. So now we will just add another content, and we will see that this content will be auto-deployed into our production without affecting the end user experience. So just by changing and committing what we did on the master branch, which is what every developer will do when deploying a new feature to production. And you see we have a target branch input that we can change if we don't want to commit directly to master. So now if we go back on the pipelines, we will see that we have our test running with the latest commit, update index.html with what we just did. And here we have the deployment that is taking place. So now our node has just been redeployed with the new version. And we will see that the website is up to date. So if we reload the page, we will see our latest changes. So HP CI/CD demo, that's what we just change in the GitLab repository. So now we will show how we can scale our application. But before that, we need to remove the services from our cluster, because in the version of Docker 1.12 that we were using, there was an issue with networking between services. So we had to do that, but in the latest version, which is Docker 1.12.1, you won't have to do that anymore. It has been fixed in the latest version of Docker. So now we're redeploying our application by launching the process in GitLab. So you see in the visualizer that our application are spawning. So we have our database and our front-end application again. So if we go back on the website just to check, we'll see that it's now deployed. The counter is back to 1 because it's a new database. And if we reload the page, it's working as expected and as before. So now we will show how we can scale this front-end application, and how we can do that easily with only one command. So by typing docker service scale, the name of the service and the number of instances you want, you're just scaling the application, which will be load balanced inside Docker Swarm. So you don't have to configure anything, and the front end will be load balanced for the end user. So that's really something that is really important in this Docker Swarm. It's a huge Docker Swarm feature. So now you see that the host name is changing just above the counter when we refresh the page. So it's basic round robin load balancing.
And now for the latest part of this video, we will show how the cluster will react on a failure. So in order to simulate that, we will stop the service on the second worker. Okay, so I have just done it. So what we will see in the visualizer, we will see that the worker 2 will become red. Okay, so the cluster has just detected the problem, and now we can see that our containers have just been spawned again on the two remaining nodes. And if we look at the application, we can see that the application is still running, and we can see that it is still load balanced. That's the end of this video. We would like to thank you for seeing this video, and our both contacts are available on that latest slides. If you want to send us some comments or feedbacks, we will welcome that. And we hope we will see you for a live demo soon. Bye bye.